I saw one of these at work, and I was wondering if I could tap into its data to visualize what it sees.
This is a photocell. It can react to changes in light intensity. Ha! Let's see what we have inside. Positive, negative, and signal. You see, the source of its jitsu lies in a special material sensitive to light on a ceramic or plastic substrate. Or, if you want to get fancy, call it a light-dependent resistor. For the base of this build, we'll use my proto board. The DIN mounts don't fit on the rails, so I'm going to remove it.
As I assemble this contraption, I want to show you the linear version of this build. All I did was take our sensor and the Arduino and mount it on this DIN rail mount using a couple of standoffs that I found. And then I attached all of it to the DIN rail. You already watched me terminate the wires to the sensor. So, I landed signal to analog 0, negative to ground, and positive to 3.3 volt pin. With that being said, let's go back to the build.
Where were we? Oh yeah, the photocell outputs different levels of voltage as a signal. That's why we are using the analog pin. It's safer to use 3.3 volts over 5 volts to feed the signal to the analog pin, so we use 3.3 volt pin. And to close the circuit, we attach the positive to the ground pin. Alright, time for some code. Open up the Arduino IDE. We can go ahead and delete that. In setup, we initialize serial communications at 250,000 bits per second. In our loop, we create an integer named PC value to store the reading of our analog 0 pin. Analog read is used to convert the voltage signal from the photocell into a digital value. Serial print line is used to print the value of our integer. Lastly, we can delay the time between the readings for stability. Or, that's what's supposed to happen. We'll see when we get there. Oh yeah! As you can see, the sensor is picking up a lot of light. Observe the behavior in the displayed graph. See the voltage drop as I cover the sensor? This happens because when exposed to light, electrons in the resistor gain energy. The energy allows the electrons to move more freely, reducing resistance in the circuit and resulting in an output voltage or signal closer to our supply voltage. In our case, it's 3.3 volts. Conversely, when less light is available, the photocell outputs a signal closer to 0 volts. This project was awesome. Thanks for tuning in. See you guys around.